2.8 deals with graphing linear inequalities. We are going to graph these inequalities just like we graphed linear equations. So our graphs are going to look like a straight line. Okay? So remember, linear inequalities look like linear equations look like a straight line. The only thing that is different with these is that our line is either going to be solid or dashed. Now, when we have a greater than or less than sign, we are going to use a dashed line. If we have a greater than or equal to or less than or equal to, we're going to use a solid line. Then after that, we need to figure out where to shade, because it's not just, a few points or, multiple points that make this inequality true that are on the line or close to the line. It's going to be tons of different numbers, ordered pairs, that make these inequalities true. Okay? So one way we can do that is to think, okay, where the number is either greater than or less than, or we can always pick a point and plug it in, okay, and see if it makes our inequality true or false. So this first one, this is in slope-intercept form. Our y-intercept is 0. So we're going to go and plot our y-intercept first at 0. And we're going to use our slope, -2 over 1. So that means my slope is negative, so my line is going to go downwards. So I'm going to go down 2 to the right 1. Remember, slope is rise over run. I could also go up 2 to the left 1. Up 2 to the left 1. Now, look at your inequality. Okay? It is greater than, so I'm going to use a dashed line. So we're going to use a dashed line. Okay, that goes through our points. Now, we need to shade it. Okay, so we need to figure out where to shade. Where are the numbers greater than this line? Okay, above it this way or below it. If it's greater than, it's going to be above. So we are shading everything this way. Okay, so you could shade it like this or use arrows. Now also another way you can do that is to pick a point. Now the easiest point on an XY graph is 0, 0. Now I can't use 0, 0 here because my line goes directly through 0, 0. So I'm going to just pick another point. So I'm going to pick 1, 1. That's a very easy point to plug in. So 1, 1. Now plug those numbers in for x and y into your inequality. 1 is greater than -2 times 1. 1 greater than -2. Is 1 greater than -2? Yes. So my point that I picked, I like to plot it so I remember where it's at. It worked, so yes, so I'd shade everything over here. You can also, use that to just double check it. If you think, okay, where are the numbers greater than or less than? Okay, just to double check. Always pick a point. This next one is in standard form. So if we want, we could find our x and y intercepts. So plug 0 in for y to find your x-intercept. So you have 3x equals 12. Divide by 3. You have x equals 4. So I'd go and plot that on my x-axis at 4. Then, do the same thing. Plug 0 in for x, find your y-intercept. So that's gone. So you have -4y greater than 12. Divide by -4. You have y equals -3. So I'd go and plot that. Okay. Now we could draw our line. This tells me it is going to be a solid line. So I'm going to draw a solid line. Another way, before I shade that, I'm going to show you another way to graph it. Okay? So instead of using standard form, you can change it over to slope-intercept form. So subtract 3x. So you have negative 4y is less than or equal to negative 3x plus 12. Now divide by negative 4. Because what we're doing is we're getting this over into slope-intercept form. So we're getting y all by itself. So now whenever we divide an inequality, divide or multiply an inequality by a negative, we have to flip our inequality symbol. So I have 3/4 x because two negatives make a positive, minus 3. So I go and plot my y-intercept at negative 3. I'll use my slope, up 3 to the right 4. Okay, it's the same exact line. Now, look at your inequality. Where the number's greater than this, okay, where the number's greater than this line, they're going to be above it. So above that line. Another thing that you could do is plug 0, 0 in. 0, 0 is, our line does not go through the point 0, 0, so plug that in. Now you could plug it into this equation that you changed, or your original equation. 0 times 3 is 0. 0 times negative 4 is 0. So you have 0 less than or equal to 12. Is 0 less than 12? Yes. So you would shade everything over here. Remember, you can pause or stop this at any time. Okay, so this one I'm going to plot my y-intercept at 3. Because this is in slope-intercept form. Use my slope up 2 over 1. Because our slope is rise over run. You could also go down 2 to the left 1. Now this tells me it's going to be a dashed line. Now, where the number's less than this line, numbers less are going to be over here. Okay, you could also pick a point. I'm going to pick 0, 0 because my line does not go through 0, 0. So 0 less than 2 times 0 plus 3. 2 times 0 is 0. So you have 0 less than 3. Is 0 less than 3? Yes. Now, for instance, if you would, plug your point in, say I plugged a point over here. Say we plugged in negative 3, 2. Okay, when we plug that in, that would say, my inequality would be false, so no. Okay, so then this side is no, so that tells me I should shade to the other side of the line. So y is greater than 4. Here we don't have a slope, we just have a y-intercept. Okay, so y is greater than 4. They don't tell us anything else, so this is going to be a horizontal line. This tells me it's going to be solid, so that line is going to be a solid line. Now, where are the numbers greater than 4? Okay, where are the numbers on the y greater than 4? Going up. Everything above it. Okay, pick a number, plug it in. So for instance, say let's pick 0. Is 0 greater than 4? No. So this point doesn't make it true, so up here it has to be yes. Now, these say, tell whether the ordered pairs are solutions of the inequality. We want to see, here's our inequality. We want to see if, when we plug these numbers in, if they make our inequality true. Okay, so let's first try it with our first one. X and Y. So 5 minus 4 less than 4. 5 minus 4 is 1. Is 1 less than 4? 1 is smaller than 4, so yes. So that one is good. Now we need to see if the other ordered pair makes this true. So negative 1 minus a negative 4 becomes positive, less than 4. Is 4 minus 1 is 3. Is 3 less than 4? Yes. So both of our ordered pairs made this true. So our overall answer is yes, because we want to know if both ordered pairs are solutions of the inequality. If one of these ordered pairs was not a solution, then our overall answer would be no, because we want to know if both of them are. So here's our inequality with this one. Here's my x, here's my y. For my first one, plug those numbers in. 10 times 2, greater than or equal to 14 minus 8 times 4. 10 times 2 is 20, greater than or equal to 14 minus 32. Is 20 greater than or equal to negative 18? Yes. So we're good with that one. Now let's plug in the next one. So 10 times negative 4, greater than or equal to 14 minus 8 times negative 3. 10 times negative 4 is negative 40, greater than or equal to 14 plus 24. Is negative 40 greater than or equal to 38? No. Okay, so do both ordered pairs make are both ordered pairs solutions of the inequality? No. Okay, because only one of the ordered pairs, the first ordered pair, made our inequality true. Now, a story problem. Okay, a person less than 16 years old can work up to 40 hours per week according to child labor laws. A 15-year-old student plans on working 2 jobs this summer, one at a fast food restaurant and one at a retail store. Write an inequality that represents the number of hours the student can work. Let X be the number of hours at the fast food restaurant and Y be the number of hours at the retail store. So, if we work 2 jobs, do we add or subtract our hours worked to find our total? We should add them. So X plus Y. Now that person can work up to 40 hours. So these hours have to be less than or equal to 40. So this says that our total hours here have to be less than or equal to 40. We cannot go over 40. Now the next part of this says if a student works 24 hours at a fast food restaurant, what is the maximum number of hours they can work at the retail store? So if you don't know how to solve this without plugging it in, without just using your mental math, then plug these numbers in. 24 is X. So 24 plus Y less than or equal to 40. Subtract 24. So Y is less than or equal to 16 hours. So they can work up to 16 hours. They can work 5 hours, 4 hours, 10 hours, but they can't work anything over 16. Okay, they could work up to 16. Okay, the last one says a chemistry exam included multiple choice questions worth 3 points each and fill in the blank questions worth 2 points each. The highest score in the class was 88 out of 100. Okay, so I've underlined some important things there. Write an inequality that represents the number of multiple choice questions and fill in the blank questions that could have been answered correctly by any student in the class. So multiple choice, those are worth 3 points. Okay, so I'm going to put 3x because we don't know how many we got right. Plus our fill in the blank questions, 2y. Now these are have to add up to be less than or equal to our highest score in the class. Okay, because our highest score by a student was an 88. Now, is it possible that someone answered 13 multiple choice questions and 25 fill in the blank? So we need to plug those numbers in. Plug that in for X, plug this in for Y. 3 times 13 plus 2 times 25. We want those to be less than or equal to 88 because nobody scored over an 88%. So 3 times 13 is 39 plus 50. So 89 less than 88. So could this have happened? No, it could not have, because our highest score was an 80.